And like the handlebars.
All right.
Maybe we just.
All right. Hi. Hello, everyone. Hello. Hello. I'm here finally. So the midterm is kind of coming up. I wanted to show you what the 2024 was like. I guess the other ones are posted as well. So some of it was, I mean, I'm talking about the 2024 midterm, but like if you look at a few of the others, obviously kind of there's new questions every time, but there's themes to it. So here you just have something from the pointer exercises. Here you have just something to write in C, so something like lab 1, something like that. Here you have change. So code so that the values of the array are printed in increasing order, separated by commas. So you could use qsort the way you use qsort in project 1, or you could implement a sorting algorithm of your choice and just again use code, the kind of code that you would use in the lab, right? Something like that. This was actually given if you want. So if you haven't used qsort yet for project 1, so that's the kind of thing that you get. Okay. All right. So here we want last occurrence. So the last occurrence of str2 in str1. So the idea here would be, well, like you can literally just do something like this. So just call a version of strcmp. So that was in the handout. There is a version of strcmp which says, I just want to compare the first n characters. And then you just like repeatedly compare the first n characters where n is the length of str2 to the beginning of str1, str1 plus 1, and so on. Make sense? So again, kind of something that's kind of like project 1, kind of the lab. I don't know how many people have started project 1. Here we have last occurrence, but it has to be recursive. Sorry, first occurrence, but it has to be recursive. So this is kind of similar to the kind of thing that you did with recursive functions. With recursive functions and strings in the lab a couple of times, and we've done it in lecture a couple of times as well. And then question 4, actually useful to look at it several ways, because question 4 was essentially a subset of project 1. So it's like a simplified version of what you need to do for project 1 when you're reading in the terms. So here, the terms that you're reading are like this, where it's a student number, which you would store as a car, and then you have and then you have kind of marks for each student. And I believe what we had you do is like, yes, so you can have up to 10 marks. So you're reading in up to 10 marks over here. Multiple ways of doing this. So like in project 1, I actually recommend just writing a for loop to do that. And here you have an example of doing a for loop in order to read in a file in this kind of format, right? So you just like keep keep reading and keep converting those guys to integers with just str with a to I, right, is the library function for converting strings to integers. Make sense? So again, like looking at those solutions actually might be useful for like if you're stuck on reading in the terms in project one. It's not exactly this, but it's kind of like this. And the idea here is that people were doing, the project one last year, and this was kind of like a subset of that. Obviously, not a super easy question. So we also needed to get, I guess, so read this in and I guess get the student whose average is the highest or something like that. So that's the second part of the question. All right. So that's like this. And then so question 6 is not going to be relevant for this year. So we kind of haven't really done this kind of thing in 180. So last year, kind of the last lecture of 180 was this. This year, I think, as well. But then we kind of repeated it in 190 so that it was officially part of 190. So I asked this, but I'll figure out something different to ask. Okay, so that's 2024. So I think kind of 2023 was like that was like one of the ones that were done quite poorly. Like maybe you might have heard legends about it. So the reason it was done poorly, I would say, is so there is a linked list here, which we'll do today, right after I do this. So that you can't yet look at, but you will be able to look at momentarily. There is like strcat_rec, which is just strcat recursively, something that you've done a lot. There is a slightly more difficult version, maybe, or about this, well, slightly more difficult version of reading in a file in the style of project one. So that was free. And then there was a question that was kind of in the style of questions like 40 through 45 in the pointers exercises, kind of combined in a new context. So this is what it is. I'm just telling you what it is. So it's like figuring out, okay, you have like the kind of stuff that we talked about yesterday. So you have like pointers to a block of pointers to structs, essentially. And then you had the famous pi integer question, which was basically what you've done in the lab and basically the kind of thing that we've done the other day when we defined a struct that operated like a string. So, an ADT that's an integer. So the issue there is that people had, and again, we haven't done this kind of thing this year, so maybe arguably you can't even quite attempt it because we haven't done this kind of math in class, although everything that you need to know in order to do it is there. So essentially what you needed to do is store a bunch of digits as characters. So that would be the integer that you're storing. And then the first question was to implement ++. So to implement an operation that would change the contents of those guys to those guys. So you would need to do basically long addition. +1 is not really hard to do, right? And then you would have the new integer stored here. So I think a good exercise to do. Arguably not something that it should have put on the test. Not very many people enjoyed it. So that was this. So I think in terms of so this is just what I said, but broken down into subparts. I think as far as looking at what the midterm is going to be like, so probably most like those guys and those guys. This was the COVID year midterm, so we were still all online. This was this was done online. You were given, like, here's the thing to implement. And then you submitted it on Gradescope. That was obviously kind of before GPT was available, but not as conveniently. So anyway, this was done like fully online. People just submitted it during midterm period to Gradescope. Not going to happen again, but you can use it for practice. All right. So that's the midterm. So basically, again, same as 180. What you want to do is you want to be able to do the labs. I'm sorry, I'm behind on posting kind of the videos with the solutions. I will try to get on that in the coming days. But doing your own solutions obviously is the way to really understand things anyways. And you want to be able to have done the project yourself from scratch, even if you work with a partner or whatever. Eventually, kind of, you want to know everything that's there. So that's the midterm. All right. Questions about anything? All right. What's the score saying? Okay. Okay, that's the. Okay. All right. So that's that. So I want to go back to implementing linked list. So just to point out, okay, we haven't. Wait, where's the notes? Yeah. So if you go to the lecture notes, so this is so yesterday I didn't feel that way. So I felt like you really want to type along with me. With linked lists, maybe not. So this is the first thing, and data structures, I guess. So the linked lists operations are all gonna be here, and I am gonna follow kind of what's in the ESC180 notes. Okay, the notes are linked over here. Okay, so data structures, and we are in linked list here. So that's what the code is gonna be. I want to switch the slides though. So we ended last time talking about kind of the low-level implementation for linked lists. I now want to look at the high level. So here's a picture that kind of at a high level tells you what a linked list is supposed to look like. So we have basically something like this. So we have nodes that store the data. So in this case, the data that's being stored is, 23 and -3. Each of those things, it's called a node. So nodes are just like things that connected with arrows. And we have the arrows. So the arrows are implemented as pointers, but we'll see later. So in this kind of architecture, what we have is we have a pointer to the first node, and then each node is in the chain is connected to the next one. To indicate that this is the end of the list, it says something like this. In implementation, we say that next here is just null. That's how we know that we are at the end of the list. Optionally, you can also, as part of the list, in addition to keeping track of where the first node is, you can say, I have 2 nodes in total. Okay. So so the data items are the items. So what's stored is, the data itself and the pointer to where the next node is. And then what's the list itself? Well, the list is this guy, right? So we have the pointer to the first node. We don't need the pointer to the second node because that's contained in here. And we have the number of elements. So, okay. So first, let's do it kind of conceptually. So let's say that I want to insert a new data point. So in order to do that, if I know that I want to insert like after index 1 or something, what do I need to do? I need to wrap the 34 inside the node. So have a node that contains 34 as the data. And then I need to hook up the new node that contains 34, so something that's around here, in between the old index 1 and the old index 2. So here I'm creating this object. So I wrapped 34 inside the node object. And now what I need to do is I need to point this arrow over here. And I need to point this arrow to where index 1 used to point, right? So I would be switching to this kind of situation. Make sense? Yeah.
So this case, all little one is the whole one.
Right. Yeah. So it's a little bit, so it's a little bit tricky. So the question was about the complexity. And yes, so that's exactly what I was going to say, is that's the point of it. The point is that you are able to insert without moving things around, except locally. Whether it's all one or whether it's still all then is debatable, because the only way that it's all one is if you already know the location of the node at index 1. If you don't know the node at the location of index 1, you need to first find it, which means that you got to start here, then jump here, then jump here, and that's taking O then to get to the node after which you want to insert. So depending on whether you need to find it or not, it might be O1 or O(n). Depends just on the definition of the task. It turns out, we'll see after the break, I suppose, we'll see that there is a case where you actually do know the locations of the nodes ahead of time, in which case you do have a time savings. In general, though, no, because in general, if you start with this is my list, right? My list is the link to the first and the end. Well, that doesn't give you anything, because you still need to find the index after which the node at the index after which you want to insert. All right, so let's do some implementation. So again, I'll follow the code over here so that you don't have to copy it. With that said, I will make it from scratch. So you can copy it if you find that it's useful. Okay. So I'll open a new folder. Sure. So, okay. So what do we want to implement over here? So I'll save it as LL page. So what do we want to be able to do here? We want to be able to create a linked list. So far, just a linked list with insert, but first we need to like create the linked list in the first place, right? So the way it's defined over here is like this. So we define a node separately and we define an LL separately. So that corresponds to this kind of structure where the linked list is this guy, and then it's linked to multiple nodes, but the linked list is its own thing. Make sense? So, okay. So I'll say type def. LL. The linked list object is going to contain the link to the first node, and it's going to contain the size. So that's like this. Of course, I need to have defined node here, right? So that would be like this. What goes in node? So the second thing is easy. That's just int data or whatever it is that you want to use for data. This is kind of harder because what we need is the address of the next node, but we haven't defined node yet. So for C syntax reasons, you have to write it like this. So you cannot just use node star inside of struct node while you're defining struct node, which makes sense because like you've only defined node using type def over here. But you are allowed to say struct node next. So that's kind of the usual pattern is if you're defining what's called a recursive data structure. So that means a data structure that contains a pointer to itself. Inside of it, you have to refer to it by its full name. So struct node. Make sense? Yeah. That's correct. So the picture here is like this, right? So each node contains the data, and then it needs, well, some representation, this kind of arrow. So the way we store this arrow is we're just saying we'll store the address of the next thing. Yeah. So the the answer is yes in principle, but that's not really what we want. So we want to be able to change the content. So like I might like to say I want to change the data at index 1. For that, I don't need the fact that it's a pointer. I need to get to it somehow. So, okay. All right. And you couldn't just say like a non-pointer inside a struct because then there would be like infinite recursion essentially. So, okay. Okay. All right. Let's do a create. Something like this from R. Sorry. So let me just see how we wrote it here. So this was this. Okay. So what are we doing here? So here we're saying I want to be able to create it from main. So the main is going to be in a different file, but I want inside of main to say, you know, my IL like this. And then I want to create it from data. So I would say like create LL from data. Right. So that's what I want to be able to do. Does that make sense? So because this is like this, I want to send a pointer to a pointer to LL so that I can set my LL to whatever makes sense. Yeah. So, okay. So let me define it over here and move it to ll.c. Wait. Okay, so that's like this. Here it's like this. Here I'm removing the braces. And now I'm ready to implement it. So this is just the usual way that they pass an array, right? So I pass the address of the first element and I pass the size. So I'm calling it using this would be address of PLL, and this would be data array, and this would be size, like whatever data array is, whatever size is, right? All right. So if I want to, well, like this. So if I want to create LL, that means that I want to set star PLL to something. Parentheses. So this is just one single object, right? So remember, what we're doing here is we are creating this guy. Inside of it, it's going to have head and size and stuff like that, but that's separate. So we just want one of those. And then we'll be creating multiple of those. Make sense? Is that good? Not good? Yeah. This part. So essentially, what's a linked list, at least in the picture that we have over here. In the picture that we have over here, a linked list is this and this, right? And then there is as many nodes as you need over here. So what we store in LL is this guy, so the pointer to the first node, and we store the size. Don't store anything else. So we need enough space to store basically this part, and then we'll be creating this and this and this and this. Okay? All right. Nothing? Okay. So, all right. So we are over here, and this is like this. So now what we need to do is we need to be creating a bunch of nodes and chaining them to PLL, right? So initially, I'll say, and I'll say PLL size is 0. As Z. And I'll include activity_lib so that it doesn't complain about the null. So, okay. So what do we want to do now? Now we want to create a bunch of nodes and change the nodes to the head, right? So okay. So here's one way of doing it. Actually, sorry, let me just check very quickly if that's the way we're doing it. Yeah. So we'll do a create node function over here. And we'll do a create node function. And here we'll do the same thing. So pn. Here we'll store fascinating. In here we'll store the data as data. And we'll store null as next. Okay. So now that we've done it, we can go and create the linked list. So we'll be essentially repeatedly creating nodes and chaining them to head. So the first one is going to be special. So the first one, we want to say if we are attaching the first node, then head needs to be pointing to it, right? What we can do is we can say, okay, so the current node that we are processing is going to be eventually head, but we need to first we'll need to first create it. So I'll say, okay, so node cur, I'll create a node. That would be something like this. And then what I'll do is I'll chain the cur. So how do I do that? Well, will need to say something like head is cur. Okay. So I'll fix this code in a second, but what is it that we're trying to do here? We're trying to say, okay, star PLL head initially is null, and we want star PLL head to be the address of the first node in here, right? So if you're looking here, so head, this guy here called first, needs to be the address of the first node. So we create the first node, and then we say, okay, like LL head is this guy. Okay. So you can also look at it in terms of the types. So what's the type of star PLL head? Well, LL is defined like this. So this is node star head. This is the address of the first node. So here we created cur. Cur is of type node star. We set cur to be something that makes sense. So cur is now a valid address. And then we're copying this valid address to head, which is also of type node star. So now this contains a valid address. And that address is of the node that we just created. Make sense? So, okay. So this only works if there is actually an element that's of size 0. So we need to kind of worry about this a little bit. So I'll say int I and I'll name it like nodes inserted so far. And I'll just say something like while I is smaller than size, so that this only happens inside here. And now the first time that we're doing it, we want to say that head is cur. The next time we're doing it, we want it to be that that the previous node next is cur. Okay, so so multiple ways of doing this. So I can, for example, say here node prev initially equals null. And here I'll say, okay, so if I is equal to 0, then it's a special thing. And we want to do this. Else, we want to say prev next is cur. And either way, we say I++. This was just old code. Makes sense. So what we keep doing is we keep setting cur to be the address of the new node that we've created. So in this case, we've created the node data array I. And then we've created it. We need to say previous next is the new one, the new guy here. After we set previous next, we can say previous is now cur. Make sense? So again, kind of what we're doing here, we're basically saying start with just this being null and this being nothing. We need to update it, by the way. And then create this guy and make head be equal to the address of this guy. And then create this guy and make this next be the address of this guy. And then create this guy and make this next be the address of this guy, and so on. So the only thing that's left is to keep increasing the size, or we can just do this. And then at this point, everything will be set up. Yeah. No, so I only check I equals 0 because when I equals 0, so when I haven't inserted any nodes so far, what I do is I set up head to curve. So that's the special case.
That's what we all think. Unset, like.
Oh yeah. So I need to here say prev is equal to cur as well. So actually, let's do prev equals cur over here. Thank you. All right. Okay. No time to test it. There's gonna be office hours. I'll announce some for tomorrow. When's your thing due tomorrow? Like for practice. Oh, Friday and Sunday. Okay. So in that case, I'll announce some office hours, I guess, kind of for the project and stuff. And I'll see you there. Otherwise, enjoy your break. See ya. Bye. Yeah. Yeah, what's up?
Wondering why we have a star here instead of this PLL arrowhead. Especially that's different from what we've done previously.
No, it's actually kind of similar. So note that that PLL is a type LL star star. So in order to get to head, it needs to be that the variable before the star is of type LL star, which it is if you cancel one of the stars.
Is it because head is
No. It's because PLL is of type LL star star.
Why is it
It's of type star star so that we can send the address of a pointer so that you set the pointer outside of the create function to. Right. So what we want to do is we want to create where is it? So we want to do something like this, right? So we want to say we have a variable of type LL star, send in its address, and make it so that my LL now has the right value.
I'm not quite understanding how that works. Why don't we just send in something that like MyL F type LL?
I mean, you could, but that's kind of the standard thing, right? So if you want to change the integer or something,
you send in the address and they say the
right,
value at the address.
right, exactly,
So-
and that's exactly the same thing.
So we're sending in type. We're sending in like LL star MyL.
That's right. That's
that we
right.
could change
So that we can change the value of my LL.
change the value of MyL. So that means like change its head, change its stuff. Okay.
Yeah.
So in this case, so what are we trying to do here then? We're trying to change its head, no? Be the current pointer, I mean the current node
That's right.
we're looking at.
That's right.
Okay. So then So PLL is of type node star, so we take the star, so now we're looking at the node, but the node doesn't have a head, so how does that work? Why isn't it just PLL? Because PLL is of type.
PLL stop LL star star. In order to
Okay.
access the field, you need for it to be a pointer to the struct, not a pointer to the pointer to the struct.
Okay, so it's the type star star, so now we're pointing to the address of it. Address of.
Yeah, so yeah. So I suggest like don't think about it in terms of like how does it all fit together. Think about it in terms of
Let's
okay, like what's the type here? The type here is the type here is LL star. So that means that in order to access something like this, it's got to be that this is of type LL star.
What is the non-syntactic sugar version of that?
I mean,
Is it-
just star. So just like star PL.
Dot head.
Yeah.
That's sure PL dot head. What's confusing me is that like the head refers to something of type LL, not type LL star star. So why it doesn't work?
No, like head is of type node, right?
But it is within a struct called LL, it's not within the address of a struct.
Okay,
It's like-
well, and this is an integer.
So okay, so we have PLL, which is of type LL star star.
Yeah.
Okay, so then that means we want to change the value of its address. We want to change the address as opposed to the value of the at the
We
address.
don't want to change the value of the address, so we want to change the we want to change the address
itself.
Yeah,
So
so
that
we
it
store
points to
the
a different node.
yes. So we start with this guy, which is not a valid address, and we want to make it be a valid address.
Okay. So are we passing myll into here?
We're passing address of my
The address of myll. Okay, so it's passing in the address of myll because the address of myll points to myll, which points to an LL. Yes? No?
No. Like or NLL if
the
that's what you
address-
said. Yeah. So it's an address of a linked list. Yeah. So
It's a trace.
or like it's an address of this kind of thing.
Okay, so so let's say we had let's say we had a variable called PL. Does that mean that and PL is
No,
is
it
of
doesn't
type-
doesn't mean anything. Like names are just names.
If I had, say, value of PL and I had and PL, would that be of a type star?
No,
PL?
like those are just names. So ordinarily, kind of depending on the convention, we add the p underscore to indicate kind of pointer to, but that's just a name.
What does and do? Is it turning something
Address
into
of,
address of?
right?
And then star also means address of,
No, star
it doesn't.
means the value at the
the
address.
value at the address of.
Yeah.
So L star myL means myL points to a value of type LL. So then and myLL means it's the address of the value that the address of the pointer that points to an LL.
Yeah, and like and you can kind of read it off here where it's a pointer to a pointer because it says pointer.
What is the pointer pointing to?
Say again?
So it's the star. What is it pointing to? Because
Well,
passed in
the star
address.
is not pointing into anything. It's like so
What?
PLL is of this type.
Why does and myLL count as type LL star star?
Because
valid.
because myLL is of type LL star,
But and myL isn't a pointer, it's an address.
and a pointer is an address.
Pointer is an address.
A pointer, like a pointer is just another word for address. Yeah.
So myL is the address of an LL, and therefore and myL is the address of an address, which is what LL star star is just the address of a pointer.
Yes.
Okay, so that means that PLL is the address of a pointer that points to an LL.
Yes.
Okay. So, okay, so now that we've passed that in, we're saying that the value at address PLL, so that means that we're changing the pointer that points to the LL. Okay. Okay, we're making it mutable, I guess, to the malloc, right? We're making it changeable.
I mean, and something that's allocated using malloc, it's true that it's changeable. It's not that we're making it so.
Why did we malloc it?
Because we initially don't have it, right? So we start with myll, which is not anything, right?
Mm.
It's not a valid address. So what we're doing when we are defining it over here is we're saying make LL be something that actually makes sense.
Okay. Okay, so then in the next one, see, I'm confused why it's star PLL arrowhead instead of just PLL arrowhead. Because star PLL is
So that's
it's not of type
because
LL. It's of type pointer to LL. So
which
why-
is exactly what you want for the arrow, right? So if it were of type
Yeah.
LL, it would be dot.
Forgot it right over here. The head, so.
Right? So for accessing fields from pointers, that's arrow.
But but the variable called head isn't stored in the pointer, it's stored in the LL. So like before you showed me a different thing, it was for the struct students. And there we never had the star. We just had, say, something of a type
Well,
student star, and then pointed.
that just means that it's a different variable, right? So so note that we work with SZ exactly the same way that we work with head, right? So we say this is null and this is size. So maybe that's kind of the source of the confusion. Like this is not head, right? So that's not the pointer, and works the same way. Right.
I said that in previous structs, we didn't have star, then the thing pointing. It was just no star, then it points.
That's just because, in the same way, kind of that here we have a star and here we don't have a star. Like that's the analogy. They're just variables of different types.
So it doesn't matter.
I mean, it matters depending on what you want to actually store, but you can store both pointers and integers.
But the value at PLL isn't an LL, it's a pointer. So how can you change head if the head doesn't belong to PLL? It doesn't belong to the value at PLL. It belongs to the value that is at the pointer that PLL points to.
Yeah, and that's the usual situation, right? So if you have so here we're still at dots.
Okay.
So this is this kind of thing,
See,
right?
there's no star, it just says PS, then arrow Jenny. Well,
Yeah, but what do you think is the type of name?
I have a name is probably it's an address. It's the address of the first character. It's a string.
Right, which is well, so in this case, in this case, it's a string. It's an array, but it could be a string, right? So it could be kind of a car star.
Okay. But then why isn't it star PS? Why is it just PS? Like, why is it PS arrow as opposed to star PS arrow?
So the way, so like forget the name. So like if you want to access age and you just have a student, you do s.age.
Mhm.
If you have a star as a student star, then you do PS arrow age.
Okay, well, but PS is of type student.
No, it's of type student star.
No, it is. Okay, wait, PS is of type student star. So this is just going to the value at PS, which is of type student.
Right.
And that's, but like PLL is of type star star. So isn't that going to the value at itself, which is just a star? It's not of type, it's not of type LL.
It's of type LL star
Then how can you
in
change,
the same way
how can you
that
change head?
same way you can change H here. Are you okay with this one?
This one to me makes sense because PS, like the value at PS is a student. It's
Yeah.
not a pointer to a student, it's just a student.
Yeah, and
But
the
in-
value at star PLL is LL star, is of type LL star as well.
Okay, but
So that means that
if
the
you do it
value,
with a star, then that's not of type student anymore. It's a pointer to a student. So how can you change head?
yeah, totally. So
How can you change head? It's not a student. I mean, it's not,
no,
it's
no,
not an LL.
no, it is, right? So PLL is not an address of an L, but star PLL is, right? So star PLL,
How can star PLL be an LL if it's a pointer?
so it's an address of an LL in the same way that the student star is an address of a student.
But when we take the address of a student and then we do the pointer, you're going to the student. We're going to the value at the
Yeah,
address.
and that's what we're
But
doing
that,
here.
then why isn't it just PLL? Why is it star PLL? Or why isn't it star star PLL?
So you could do it with a star star PLL. You asked about it before, and then you would use dots. So the arrow. So like think about the simplest situation. So here, PS is of type student star. So PS is not a student. PS is a pointer to a student, the address of a student.
Okay.
And then in order to access the field at the pointer, you are using the arrow. Or you could say star PS dot H.
Okay.
Right? Same thing here. The only difference